Welcome to this video on factoring the sum and difference of perfect cubes. Let's get started. First, let's look at which of these variables with exponents is a perfect cube. Well, x to the third is a perfect cube because it's x times x times x. We have a perfect set of three variables. What about x to the fourth? Well, that's x times x times x times x. We don't have one or multiple sets of three, so this is not a perfect cube. Likewise, x to the fifth, we have 5 x's. We have one set of three, but we don't have two sets of three. So what about x to the sixth? Well, that's 1, 2, 3, 4, 5, 6. So now we have two perfect sets of 3 x's. So x to the sixth is a perfect cube. Okay, we could also write it as x squared times x squared times x squared, if you want to think about it that way. So anytime your exponent is a perfect, if your exponent is a multiple of 3, okay, then your variable, or your term rather, is going to be a perfect cube. So again, x to the 7th would not be, x to the 8th would not be, but x to the 9th would be, because 9, of course, is 3 times 3. So you have 3 sets of 3, or you could also write x to the 9th as x cubed times x cubed times x cubed. It's another way to think about it. So that's how we think about variables. So again, if we have a variable with an exponent that has a multiple of 3, then we know that that whole term with its exponent is a perfect cube. But what about numbers? Well, numbers kind of follow the same rule, right? We have 1 times 1 times 1, that's 1, right? Or 1 cubed. 2 times 2 times 2, that's 2 to the third power, or 8. We have 3 times 3 times 3, that's 3 to the third power, or 27. And, we can continue the pattern. We have 4 cubed, that's going to be 64. 5 to the third power is 125. 6 to the third power is 216. And, of course, you can use a calculator to continue this pattern if you'd like. So let's get started with, to find out, now that we know the definition of perfect cubes, well, what are the formulas for the sum and difference of perfect cubes? So these are the two formulas that we have right here, the two equations. And unfortunately, you're going to have to remember these. You're going to have to memorize them for a test and then also on the final exam. Okay? So we have this cute little memory tool. The acronym is SOAP, as you can see here. And SOAP stands for same, opposite, always positive. So what does that mean? Well, that's really just talking about the sign. So if I'm adding, if I have a sum, the first sign that I see is also a sum. So in other words, this sign is the same as the original sign. Then the next sign, notice it's a subtraction sign. That means it's the opposite of what we started with. And then the last one is plus. And in both situations, hopefully you can see that they're both positive. So we just say that the last sign is always positive. Okay, so again, if I have a cubed minus b cubed, that's a minus b, so the first sign is negative. Then, so that's the same. The second sign is positive, that's the opposite sign. And again, the last sign is always positive. So that helps you keep your signs straight, but you still have to memorize the fact that, a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared, and a cubed minus b cubed is a minus b times a squared plus ab plus b squared. And of course, a and b can be anything that you want to. All right, let's do an example. So the first step that we want to do, we have the expression x cubed minus y cubed. So the first thing we ask ourselves is, what is the GCF? Remember, that is our general factoring strategy. In this case, the GCF is 1, so we're going to move on to step 2. So step 2 says how many terms do we have? So we can see clearly that we only have 2 terms. So we're going to try either a difference of squares or a sum and difference of cubes. So hopefully we can all agree here that x cubed is a perfect cube, y cubed is a perfect cube, so we have a difference of cubes. So that means that since we have a difference of cubes, we are going to be using this equation to factor it. Now, this is an equation or a formula that you have to memorize. It is not going to be given to you. So let's see, if we have x cubed minus y cubed, right? Well, that fits the form a cubed minus b cubed, okay? And the way we factor it is a minus b times a squared plus ab plus b squared. So in this example, a is x and b is y. So wherever I see a in the equation, instead of a, I'm going to write x. And wherever I see b in the equation, I'm going to write y. So we have x squared plus xy plus y squared. And that, my friends, is the final answer. That's it. So remember, you can always pause this video if you get stuck, or watch it as many times as you want. You can watch it on 2x speed, or you can watch it on slower than normal speed, just to make sure that you understand it. So let's do another example. This time we have 8y cubed plus x to the 9th. So again, we look for our GCF. The GCF of the whole expression is 1. So then we ask ourselves how many terms. There are 2 terms. So we try to find either a difference of squares or a sum and difference of cubes. Well, 8 is a perfect cube, y cubed is a perfect cube, and x to the 9th is also a perfect cube. So we therefore have a sum, we have a sum of cubes, which is this equation right here. Okay, so remember that equation is not going to be given to you, so you have to figure it out. So a cubed plus b cubed, okay, so that means that a cubed, a cubed is 8y cubed, and b cubed is x to the 9th. So what we need to do is we need to solve for a, figure out what is a, and we need to figure out what is b. So a cubed is 8y cubed. Okay, to figure out, well, what is just a by itself, what we would need to do is we would need to take the cubed root of both of these. So a ends up being 2y. If you don't believe me, you can show this is true by saying 2y times 2y times 2y, or in other words, 2y times itself 3 times is 8y cubed. Okay, so again, a is 2y, and then we have b cubed. B cubed is equal to x to the 9th. So I have to take the cubed root of both of these, and we find out that b is going to be equal to x to the 3rd. And again, if that confuses you, or if you're not sure that that's true, you can just remind yourself that x cubed times x cubed times x cubed is in fact x to the 9th. Okay, so wherever I see an a in this equation, I'm going to end up writing 2y. And wherever I see b in the equation, I'm going to be writing x cubed. So I think we have enough information now to actually start and write our equation. So I'm going to write out the formula here. Separate out some room here. So we have a cubed plus b cubed equals a plus b times the quantity a squared minus ab plus b squared. Okay, so underneath of that, remember, we're going to write 8y cubed plus x to the 9th. Okay, and then this is where this comes in. Okay, again, wherever I see a, I'm not going to write a, I'm going to write 2y. So we're going to write 2y here. Okay, and then, again, wherever I see a b, I'm not going to write b, I'm going to write x to the 3rd power. This is x to the 3rd power. Okay, then we have a squared. Well, what's a squared? Well, let's figure it out. A squared is equal to 2y quantity squared. Well, that's 2y times 2y, so that's 4y squared. At the end of our equation, we also have b squared. Well, what's b squared? Well, that's x to the third raised to the second power. Remember, when you have a power raised to the power, you multiply. Or you can also think of it as x to the third times x to the third. So that's going to give us x to the sixth power. So now we have all the information we need so we can finish this problem. So we have 4y squared minus 4x to the sixth y squared plus b squared, which is, oops, I'm sorry, this wrong. I apologize. Sorry, guys. Minus ab. So we're going back to this a, which is 2y, and this b, which is x cubed. Okay. So minus 2y x cubed plus b squared, which is x to the sixth. Okay. So this is our final answer. The only thing that I might be tempted to change is we usually write our variables in order, in alphabetical order. So instead of writing minus 2yx to the third, I would probably want to write 2x cubed y. Just out of, just because that's what we usually do. So that's our final answer. So again, 8y cubed plus x to the ninth is equal to this factorization right here. All right, let's see if we can fit in one more problem. This time I'm going to do this problem right here. 2x to the sixth plus 54. Well, x to the sixth is a perfect cube, but 2 and 54 are not. So what can we do? Well, remember, our very first step should always be to find our GCF. In this example, our GCF is not 1 anymore, it's actually 2. So the first thing I can do is factor out a 2. So I get x to the sixth plus 27. Okay. Then I notice that this is in fact a perfect cube, so I can continue to factor it as I would a perfect cube. So at this point, we have a sum of two perfect cubes. So remember, we have same, opposite, always positive. Okay? So a cubed is going to be x to the sixth, and b cubed is going to be 27. So what does that mean? If a cubed is x to the sixth, then that means a is x squared. If b cubed is 27, that means b is 3. So we're going to have x squared plus 3. Then we have a squared. Well, what is a squared? Well, a squared is x to the fourth, and b squared is going to be 9. So we have x to the fourth minus, well, a is x squared, b is 3. So we're going to have minus 3x squared plus b squared, which remember we said was 9. So this is our final answer here in factored form. Oh wait, I forgot something. So, right, all I've done so far is factor this. Okay, but we forgot about this 2, right? The 2 is also part of this. So if I put this all together, I have 2 x to the sixth plus 27 equals 2 times x squared plus 3 times x to the fourth minus 3x squared plus 9. Okay, so again, right, this 2 is still part of this factorization, so it also needs to be part of your final answer. So this is the correct factorization. The only thing I did at the very end was to reintroduce this 2, because again, that 2 is part of the problem as a whole.